So there's a right triangle here in the middle. I'm given 30 and 90, so this one has to be 60. If across from 30 is 5, across from 90 is 10, across from 60 is 5 root 3. Now I can label this as a 30, 60, 90, and across from 90 is 10, so across from 30 is 5, and across from 60 is 5 root 3. And here I can label this as 60, across from 90 is 5 root 3, so across from 30 is 5 root 3 over 2, and across from 60 is going to be 5 root 3 over 2 times root 3, so 5 times 3 divided by 2, or 7.5. So I now have the two dimensions. If I take 7.5 times 5 root 3 in a calculator, you get 64.95. First up, I'm going to divide this hexagon into 6 equal triangles. And they're all going to be 60 degrees for the central angle. So if I cut that straight in half, I'll have a 30-degree angle, and this will be divided into 2 and 2. Now we have a 30, 60, 90 triangle. So if there's a length of 2 across from 30, across from 90 is 4, and across from 60 is 2 root 3. So if this repeats down here, also 2 root 3, well, that's the height of my square. But I guess we can just bring 2 root 3 over here. And remember that this length was 4, so this length is also 4, so this length is also 4. All these distances are 4. So can I figure out this part using the Pythagorean theorem? Turns out I can. 4 squared is equal to 2 root 3 squared plus, we'll call this x squared. So this is 16, this is 12, and turns out this is 2. So to find the area of one of these triangles, I'm going to take 2 times 2 root 3 divided by 2. So in other words, 2 root 3. There are 4 triangles, so if I multiply this by 4, I get your answer 8 root 3, which I think is A, though the multiple choice are missing from this video. The area is 432 square inches, and they tell us the length is x. So 432 would normally equal L times W, length times width, but I'm going to put XW, because that's what length is equal to here. And they also tell us that the poster is 6 inches longer than it is wide. So I could write this as x is equal to W plus 6. I can also rearrange this to say that W is equal to x minus 6. So now I can get rid of the W and replace it with x minus 6. And I get x squared minus 6x. And the reason I do it this way is to get rid of all the W's and solve for L, or x, which represents the length. So if I consider a slice of this hexagon and blow it up over here, this bottom angle is going to be 360 divided by 6 because there's 6 little triangles. If I cut that exactly in half, I have now created a 30, 60, 90 triangle. And if this entire length is A, half of that is A over 2. So if across from 30 is A over 2, across from 90 is just A, and across from 60 is A root 3 over 2, which is my apothem. So now I can use the formula for the area of a regular polygon, which is 1/2 times the apothem times the perimeter. So here this will be 1/2 times A root 3 over 2, and the perimeter is going to be 6A. So if I plug in and combine, and now I can cross out root 3, and I'm going to multiply both sides by 4 over 6, and I get that A squared is equal to 256, or in other words, A is equal to 16. So let's go back over here. They tell me the length of one side is A, so this turns out to be 16. So I just take 16 squared, and the answer is A. So here are my two squares, ABCD and EFGH. You can see that ABCD has a side length that's double. Down here, my area is equal to 9, so that must be s is equal to 3. So now this is 6. 6 times 6 is 36. Length is w plus 5. Area is equal to L times W, so 104. So I can replace L with what it's equal to. And now I know that W times W plus 5 is equal to 104. W squared plus 5W minus 104 is equal to 0. And I'm guessing it's going to be somewhere around 10. So it turns out it's 13 and 8. So W plus 13, W minus 8. If you multiply these two, you get 104. If you add these two, you get a positive 5. Now, if you ask me, it's pretty likely that the answer is not negative 13, but it's a positive 8. That tells you what the width is, but they actually want to know what will the length be. So that's the width plus 5. So 8 plus 5 is 13. So the area of a parallelogram is equal to the base, 10, times the height, 5. Notice they're perpendicular. So the answer is 50. If I look at my original container, I can find that the area is 12 times 9, or 108, and there are 12 glasses. So I'm going to divide by 12 and find out that each takes up an area of 9. If I double the length and the width, my new dimensions are 24 and 18, so I multiply those two. My new area is 432. If I divide that by 9, I get how many glasses this will hold, which is 48. But they want to know how many more. So there used to be 12, and now there's 48. I subtract 48 minus 12, and that's where you get 36. So my original area was 12 times 9, 108. And we now made that 25% bigger, so we can multiply by 1.25. And the answer is 135. So this mirror has a width of 3 feet and a length of 5 feet. So the area there would only be 15. But we're going to add to that. So this becomes 3 plus 2x, and then the length becomes 5 plus 2x. Now if we multiply these two, so I can multiply those two out using the box method if I combine like terms, and remember that I'm adding up to 35 square feet, so I can move that over, factor out a 4, and there's two possible answers. Distances can't be negative, so negative 5 is no good. That means the answer is 1.